Hello everyone and welcome to my channel. This is Serena and today we are diving into the world of regression and forecast, a powerful duo in marketing analytics. If you've ever wondered how marketers can predict future sales or optimize ad spending, you're in the right place. By the end of this video, you will understand what regression is, how forecasting works, and how marketers use these tools to make smarter, data-driven decisions. Don't forget to like and subscribe if you find this helpful. So, what is forecasting? Forecasting basically allows us to look ahead. For example, what will sales look like next quarter? We can use past historical data to project future performance and make predictions, helping marketers plan campaigns or stock inventory. Various regression models are used to forecasting marketing. Let's see how forecasting can be used in marketing. Sales forecasting, predicting future sales volumes to manage inventory, optimize supply chain decisions, and plan production schedules. Customer demand forecasting, estimating future customer demand for products to adjust marketing strategies and promotional efforts. Budget forecasting, allocating future marketing budgets based on expected changes in market conditions and consumer behavior. Trend forecasting, identifying upcoming trends in consumer preferences to guide product development and innovation strategies. Let's take a look at different forecasting models. The first one is linear models. These models assume a straight line relationship between variables. They are simple and widely used for forecasting where relationships between variables are direct and consistent. Nonlinear with S-curve. This model type is used when growth accelerates and decelerates in a predictable sigmoidal shape, common in product adoption life cycles. Exponential and power models, useful in scenarios where growth increases at a rate proportional to the current value, making them ideal for rapidly growing markets. Logistic models, these are used when the growth does not just increase but does so up to a certain point and then stabilizes. This model is typical in saturated markets. And last but not least, extending linear with seasonality. Linear models can be extended to incorporate seasonal variation in data, which is crucial for businesses with significant fluctuations throughout the year, such as retail businesses during holiday season. Before we dive deeper, let's take a look at regression. So, a regression is a statistical method used to analyze the relationships between dependent and independent variables. In marketing analytics, it helps marketers understand how various factors such as advertising spend, pricing, and product features influence consumer behavior and business performance. Today I'll be showing you guys how to perform this regression analysis on Excel and create your own forecasting models. I have the sample data set of ad spend and sales. Let's see how ad spend affects the sales in this particular period of time. And for that, we can use regression. We can do regression analysis really easily in Excel using the data analysis toolpack. If you don't have these, you probably haven't selected them as add-ins. And for that, you have to go to Files, go to Options, go to Add-ins, and then click Go, and then choose any of the tools that you want to use and then do OK, and it should appear right here. So for this, let's use regression. There's many other options you can use for data analysis, and in our case we're going to use regression because we want to see the relationship between the two variables. Our y range is going to be the dependent variable, which is sales, and then our y range is going to be the independent variable, which is ad spend. And we have to mark this label right here because our dataset or our columns do have labels. And you can choose where you want your results to appear. For me, I want this in this worksheet, so I'm going to choose right here. And I want the residuals, hit OK. So here are the results. So let me explain what some of these terms means. The R square is 0.99, which is pretty great. The R square of 0.99 indicates that this model right here explains 99% of sales variation. The R square tells us if the model is a best fit to our data. And to know if it's the best fit or not, you need to look at R square values that's greater than 0.9 or closer to 1. And here is our intercept, and this is our slope. So what does this coefficient mean? Right there, our slope is 8.993. So what this tells us is for every additional $1,000 spent on advertising, sales increase approximately by $8,993. So this represents that the return on ad spend we're getting right here is nearly $9 in sales for every $1 spending on advertising. The intercept is 49. So even with advertising spending is zero, the model is predicting the baseline as of about $49 of sale. Another thing to look at in regression is the p-value. Right here, the ad spend is less than 0.05, which is statistically significant. This means that ad spend is statistically significant when measuring the relationship of sales. When looking for p-value, it has to be always less than 0.05 for it to be statistically significant. If it's greater than 0.05, then that variable is probably not statistically significant. So let's see how to do forecasting with this. It's really simple. You just have to take the coefficient of the ad spend and then multiply it by the value of ad spend. And for this, we are going to log coefficient because we don't want it to move because it's the same every time. And then add our intercept. Let's log these two. Okay, now. Okay, right there. That's our forecast and that's our actual sales data. You can also calculate intercept and slope manually with the intercept function in Excel. So known y's, which is our dependent variable, and then our independent variable. Okay, our intercept right here and right here is the same. Same for the slope. We can use the slope function, known y's and x. Okay, and we can similarly calculate our R squared too with RSQ and the same our known y's and our known x. Similarly, how we perform the regression in this dataset, we can perform multiple regression that contains two or more dependent variables. So let's look at this one. I have a dataset, just a small one, a sample dataset of TV ad spend, social ad spend, and email ad spend, and how these affect sales. It's the same thing. You just go to Data tab and then go to Data Analysis, choose Regression, and your Y range, which is the dependent variable, is going to be sales, and then your X range, which is your independent variables, are going to be these three. So again, we have labels in our data. The output range, I want this right over here. So I already have pulled my regression analysis right here. So I'm not going to click OK, but in your case, you want to do that. So how to pull up a regression equation out of this? It's pretty simple. What you do is, you see right here, email ad spend. The coefficient of email ad spend multiplies the value of email ad spend, and then it's going to be plus the coefficient of social spend is going to multiply the value of social spend plus the coefficient of TV ad spend is going to multiply the value of TV ad spend plus our intercept. So this is our forecast using all these coefficients, and this is our actual sales, and this is our forecast. It is pretty far off because of the R square value. So the closer you get to 1, the better your forecasting gets. So this is how you do multiple regression on the data set. Now let's see how to do linear and non-linear forecasting. So right over here, I have this data set of coffee sales and soda sales over a certain period of time. Let's look at the coffee sales first. So to do a linear forecasting, you can just insert a scatter plot and find a trend line that's best fit to your data. So what am I going to do is choose the data period and then coffee sales and then insert a scatter plot. And then right over here, you can add a trend line. For this, I'm going to use linear because you can see the data has consistent growth over time. And if you scroll all the way to the end, here's the option that says display R equation on chart and display equation on chart. Okay, so this is our R square value, which is 0.99, which is pretty good. And then this is our equation. So for forecast, what I'm going to do is copy this equation right over here. You're going to take this period, which is the X value, and then you can forecast all the way to September. Okay, and that's pretty much it, how to do linear forecasting. And you can use other forecasting models. You can use exponential. You just have to see what's the best fit to your data. I'm not going to use exponential because there isn't a sudden growth. You can use logarithmic, polynomial, power, whatever fits your data the best. You're going to use that trend line and copy your equation and put your value of x, and that's how you forecast using other nonlinear models. So this was our linearity. So how to calculate or forecast data that has seasonality in it? Let's pull up a scatter plot for soda. I want the line one because I want to see what the data looks like. So you can see right here that there's seasonality on the data right here. And how you can calculate that is you have to look for a certain periods of cycle that repeats over again. In this data, you can see point 1, 2, 3, and 4, and then if the same cycle repeats again, 1, 2, 3, 4, 1, 2, 3, 4. So let's insert cycle. Every cycle repeats 4 times. So we're going to do 1, 2, 3, 4, and then 1, 2, 3, 4. The best way to calculate seasonal forecasting is by using additive forecasting or multiplicative forecasting. In this case, let's do a additive forecasting. So we've already established our cycle. This period or these cells right here have 4 cycles, 4 repeating cycles. And for additive forecast, you need a base, a trend, and you need a cycle, which we have 4 cycles. And then you can just put any value right here and right here. And this right here is the average of these 4. You can put any value over here. Again, we are going to use solver, so it's going to change later. So the formula for additive forecast is right here. That's base, and I'm going to lock it in place because I don't want it to move. Our base is going to be same all the time. So base plus trend, I'm going to lock this to multiply period with this period of time, and I'm not going to lock this because I don't want this to move down. Plus we're going to use VLOOKUP, and we need to look this cycle up right here in this cycle. So I need to look this up in this table right here, and we're going to put 2 because there's 2 columns index that we're looking at, and enter, and then just drag the value all the way down. So this is our additive forecast, and right here the error is going to be the x value minus the forecast. So this is our error, and the squared error is going to be error 2, and this right here. Okay, so SSE basically means the sum of squared errors. So we're just going to sum the squared errors, and RSQ is the R squared. We're going to use RSQ function, and in this case, our known y, which is our dependent variable, is our forecast, and then our known x is right here, the actual sales. Okay, so we are going to use solver to increase our I square and then to decrease our sum of square. If our sum of square decrease, our I square is going to increase automatically. So what you're going to do is go to data tab, go to solver, and choose the R square value. We need to minimize this by changing variables, this and this. So you're going to hit control and then choose these two. So we are going to add a constraint. We want the average of this cycle to be equals to 0. We need to remove this. We need the variables to be negative for this to be 0. And we are going to use z as nonlinear and then hit solve. Okay, so right here, our sum squared has decreased to 89,641 and our I squared has increased to 0.95, which is pretty good. And this is our soda sales, and this is our forecast for the next 4 months. If you want to see how your forecast is performing in comparison to your past data, you can add it to this existing chart. You just have to select data, add, the name is additive forecast, the X value is this, and the Y value is going to be our forecast. We can hit OK, and right here is our chart. You can see that it pretty much matches the past data, and since our R square is 0.95, it's actually pretty accurate, except in some points here and there. And to perform a multiplicative forecast, it's kind of the same formula, you just have to adjust here and there. So in place of this addition, it's going to be multiplication, and in place of this multiplication, it's going to be power, and right here, it's going to be multiplication too, and then you can hit enter, and that's how you can actually perform a multiplicative forecast, and all the other steps are the same as the additive forecast, except the formula is slightly different. Okay guys, this was it for today. If you have any questions, please feel free to ask them in the comment section, and I hope you guys learned something new. Thank you, and don't forget to subscribe. See ya.